Hi, in this episode, we're going to talk about the atomic model proposed by Thomson in order to explain all the data that are available at that time point. So, atomic structure was not known, and so at that time, and so Thomson's experiments provided a very simple explanation for what is an atom and how is it structured. And so he used mainly the cathode ray tube experimental data and the previous data in order to construct his model. He proposed that matter is composed of positively charged particles, and that's simply because he found that the cathode rays are negatively charged particles. So there has to be positively charged particles. So his model was quite simple, and we will discuss this. A sphere of positive charge, which is embedded with particles of negative charge. And cathode rays and anode rays that were not yet discovered by this point allowed a better understanding of atomic structure. But since anode rays were not yet discovered, he proposed that there should be analogous positively charged particle ray, which was then later discovered. And so his model is come to be known as the Plum pudding model, where you have a uniform positively charged sphere, blue sphere shown here, and all the positive charge of the atom is associated with this blue sphere. And this sphere is then embedded uniformly with oppositely charged particles. They have to be uniformly distributed because of the repulsions between them, and so they have to be distributed. So you can imagine that a positively charged sphere and the electrons on the surface of the sphere at equal distances from each other, and so that they repel about the same amount. And so this is come to be known as the Plum pudding model. And because it has positive charges and negative charges and balanced exactly, and it explained all the observations until then, which is basically electrons are negatively charged. All matter has negatively charged electrons, and matter is electrically neutral. So all these three facts could be accounted for by his model. But this model couldn't explain atomic spectra. By that point, very detailed spectroscopic studies were done to demonstrate that atoms, under certain conditions, which we will see later in this course, emit very sharp lines. And so that could not be explained by this model. Like any other model, this has survived a long period of time until his student, Rutherford, analyzed the alpha ray scattering experiment and proved that Thomson's model cannot be correct, even though it accounted for all the observations known until that point. This is why science is very interesting, and it is willing to change itself until the reality, the truth is learned. So it undergoes a series of modifications and deductions until it is consistent with all the existing body of data. In summary, we have looked at cathode rays as negatively charged particles, and then Thomson's model hypothesized that these are embedded into a positively charged sphere to account for electroneutrality of matter. And this model explained how cathode rays can be produced from gas particles. So that's a triumph of this model. And also, this model also established electrons as the major constituents of all matter. All matter contains electrons. That is explained by this model as well.